Hey everybody, this is Larry. This is day 24 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem as soon as it loads. I'm feeling a little bit off today, so let me know. We'll see how that goes because I was outside and it was pouring, like pouring rain, super soaked. I need to get in the shower, but I want to, do this video for you at home before I do, so we'll see if that's a good decision. Anyway, today's problem is construct target array with multiple sums. You give an array target of n integers from a starting array, okay? X is the sum of all elements in the array. Choose an I, and then we set the value of that I to X, and then you do it however you like, okay? Okay. So basically, you can choose one number and then make it the sum, right? And then you have this like thing. And of course, it doesn't really like the order doesn't matter because you can always just change in some way. How do I think about this? So 1 1 1. Okay, then we have 3, right? We have to choose 3. Okay, so this 3 is forced, and then the next we have 5, and then the question is, do we want to change the 5 or want to change the 3 to 5 or the 1 to 5? And then okay, so that's one way to think about it, right? To start with an array and then see if we could get to 935. The other way, of course, is just start with this target and see if we could get to 1 1 1 1. And what would the rules be on that one, right? Well, in this case, we know that the biggest number in this array has to be, because they're all positive, there's no negative numbers, anything. So the biggest number in this array will have to be the sum of all the other numbers, right? Or the previous round. What I mean by that is, okay, so then you have 9 3 and 5, for example, and that means, what does that mean, right? That means that 9 is equal to the sum of the previous array. So then what is the previous array? Oh, this was weird. What is this? Oh, did that because this? Anyway, right, and that means that given that the other numbers are 3 and 5, then we know that previously the array is 1 3 and 5, and then now we do the same thing, which is that given this 5, what is the 5 is equal to the sum of previous array. We know that the other numbers are 1 and 3, so that means that this number used to be a 1, and so forth. So I think from that way, in a greedy way, we are able to solve this. And also in a greedy way, we are able to, I think that's pretty much it, right? In a greedy way, we always get the max number and then see what that number used to be. Okay, so I think we should be able to solve that now. Hopefully the explanation was okay. I think I kind of was thinking through it with you at home. So yeah. And the reason why I got to here very quickly is because with all positive numbers, there's really no other way, right? Like can 9 be can any other number be the sum of the previous array? Then just no, because you have a 9. So, by like some kind of proof by contradiction thing, I think that's it. Okay, so then now, and of course, now that I remember that this week is heap week, then, this is, and here again, we want a max heap. So let's get started. Again, I like to do it this way. You can do it at home, however you like. Where I pre-write the push and the pop, so I don't have to think about it. You can also probably abstract this into a class if you really like, but yeah. So then we have total is equal to sum of target, and here, I guess technically we could have heaped, but or like we could do a heap fix thing, but it's fine. This is slightly slower, but that's fine as well. For x in target, For x in target, we just push x, right? And this is a max heap because we want to get the max number out inside the array. There's one thing I want to do, and that is just, I guess n is equal to length of target. And n is both the number array, but also the answer, right? Because, or not the answer, but like that's the reverse target, because you're starting, all of these numbers are 1, so then n ones is equal to n. So that's basically the idea. Okay, alrighty then. Yeah, sorry, I'm like getting like stuffy nose just from the rain. My hair is still a little bit wet. I changed out my shirt, but it's still I need to take a shower to kind of refresh myself. But anyway, but yeah, so then now we go while total is greater than n, right? While total is greater than n, we get the largest number. So the largest is equal to pop. And then now, what does that mean, right? Well, we know the current total, so then we know that without this total, this is going to be total minus largest, maybe, right? And then now the delta is just, which one is it? So the largest number is the previous sum. So okay, so maybe you can even yeah. So then the largest is the previous sum minus the current sum is the delta, right? And then the delta is what we push back in as the thing. And then now after total is less than n, and we do get there eventually, or less than or equal to, we just return whether total is equal to n. I think that's pretty much it. Maybe I missed. I get the signs very easily wrong on some of these, but I think this is mostly okay. Maybe not clearly. Huh. Let me think about it. So 5, 8, 5 is equal to 3, 5. Oh, total, this is wrong, maybe. Because, so, okay, I think I was too fast on this one. Why do I think this is right? I don't know why. But the new total is equal to the largest, because that's literally me. Well, what I think happened here is that I kind of need to add back in delta, but this new total is just the largest, right? So, yeah, I just kind of forgot to add back in delta because we push it back, right? When we pop, we push and so forth. So that was just a silly thing. Apparently I got it wrong a few times. Hopefully today I don't get it wrong. Come on, buddy. Or maybe even time limited, who knows? Oh, I do get time limited because if we have, is there like zeros or something like this, then, yeah. Because what happens is that this row, because what happens is that this is going to have 0, 0, 9, and then, no, why is this wrong, actually? So 999, it's 9. Did I do this wrong? Let me think about this for a second. Clearly, this is. Clearly, I was a little bit arrogant and kind of did it too quickly. But okay, so we have 999. Total is 27. This is greater than 3. Largest is a 9, obviously. So, oh, I guess this algorithm is definitely correct if we assume the input is correct, right? So if this is true, this always terminate. I think I lapsed a little bit in that when it is false, the invariants are no longer true. I think I was focused on the true case where in the true case, I was focused on the invariant that happens on the true case, which is this thing. But on a false case, I didn't really consider it enough. So that was a silly mistake on my part. Okay, so what does that mean, right? So let's say 27 is equal to 3, largest is 3, total minus 9, and then this adds, so del 2 is actually even bigger than total. So, okay. So basically what we should guarantee here is that, okay, if the largest, I'm trying to think whether it should be equal or greater than, but okay, let's think about this, right? If the largest number, which is, remember that here, largest is also the previous sum, right? So if the largest is greater than, so if the largest number is less than, okay, after we subtract it, but I mean, I guess we could write it both ways. So yeah, so after we subtract it, if total is greater than largest, then we return false. If this is equal, we also return false. But in that case, delta is 0, and you push it 0, but with 0, there's no, it's not possible, right? So that's basically why I think this is okay, but I could be wrong. Hopefully this is right. Nope. What did I get wrong on? It's different. Third to last, 2, 2. 2, 2, I write true. What's this? Wow, this is hard, but that's also why you focus on it, I suppose. Okay, 4. Oh no, this is 2. This is 2. Oh, I set the same. I set. Is that? I mean, I set the right things, but then I implemented wrong because I wanted the reverse of my logic, which was why I didn't want that if they're equal, they're false. But then I think I just mixed it up in my confusion. I think this is right, maybe, or at least more right. So yeah, let's give it a submit again. Hopefully this is a little bit better. Oh no, is past Larry gonna beat current Larry? That would be sad. All right, maybe I need to slow down a little bit and see what's up. Yeah, oh, I actually did not consider this case. I didn't look at that's my fault. I did not look at the input enough because that's an obvious case. How do I do this? I think you could do a mod type thing because what we want now is this but repeated subtraction, right? And repeated subtraction is going to be a mod, so we should be okay here. But then now how do we, total is not right anymore, right? All right, let's actually rewrite these a little bit because I think I'm reusing total too much. So okay, so then okay, so let's rewrite this so that we're a little bit clearer in understanding. I am also very sloppy today, clearly. I need to be a little bit better. I blame it on the rain. So yeah, previous sum is equal to this, right? And now current sum. Let's rewrite this as current sum. If yeah, so delta is equal to how do I say this? The missing number is equal to the current sum minus the previous sum, right? Is that right? Yeah, and then we actually want this to mod, and then now what is the new sum? New sum is going to be missing. So then now, okay, so you have this missing, and you just put it back in here. But then now we want the current sum. What is the new current sum, right? Current sum is equal to the missing number plus the sum of all the other numbers, right? So just current sum minus wait. So the current sum, we want to subtract it by the delta. Well, okay, I think I mixed some stuff here. So okay, so let's just say delta is equal to this thing, right? I think I'm confusing myself a bit, to be honest. But okay, so that's the delta. So for example, okay, let's actually put something more concrete. So that means that, for example, if we have this thing, I think that'll help me a little bit because I think I'm confusing myself a little bit too much, not gonna lie. So then now current sum is equal to 17. Previous sum is equal to 8, right? Previous sum is equal to 9, sorry. And then the other numbers, other sum is equal to this, so that's equal to 8. Okay. And then now we want, well, we want the current sum is equal to the other sum plus, because that's just all the other numbers, and then it's this one. 9 is the number. So previous sum is 9, so then the missing number is equal to the current sum, maybe the previous sum minus the other sum. Okay, and then now the current sum will be equal to the other numbers plus the missing number. And in this case, we want to mod here because we want to keep repeating the subtraction. And then I think we're okay. Let's give it a submit. Oh, I just ran, not a submit. Okay, and then I forgot. Did I delete the end for some reason? Oh, total. I just say current sum is equal to this. Is that right? Guess we'll see. Nope. Why is that not right now? All right, let's make this. Let's fix this for now, just to. Let's see if the renaming fixes it for now. The renaming does not work after I fixed it. So okay. Sorry, friends. Yikes, right? Okay, so the other sum is 8. So the missing number is equal to 1, right? So it becomes 135. All right. So why is that? Okay, I'm actually getting wrong on the first one, so it's a little bit sad. But and then current sum is equal to 8 plus 1, which is 9, and then yeah, that's good, right? And then now we go to the next, and then now we have 135. The previous sum is equal to 5. The current sum is equal to, what is it, 9, which I think we do set correctly. Yeah. So that's still good. Other sum is equal to 4. Missing is equal to 9 minus 4. Yeah, 9 minus 4. So wait, what? Our previous sum. So 5 minus 4. So this is 1, right? And then now current sum is updated to 4 plus 1, which is 5, right? And then now we have 121. So why is it returning false then? Maybe I am doing weird. Let's see real quick. Maybe I have just some weird typos. Doesn't even output that much. So it just returned false here, mostly. I can't believe I have a regression, but so the current sum, yeah. Oh wait, I think I changed my. I think this is wrong. Okay. Obviously, the current sum is going to be bigger than the previous sum. I think I changed my variable names and got confused. Okay, so basically, let's go back a little bit. Basically, if the missing number, let's have it here instead. If missing is, or yeah, if the previous sum is greater than or equal to the current sum, then we return false. Yeah. I really am not feeling well today. We can remove this for just for a second. Though I think this is actually TLEs due to so maybe that's just silly. So what do we want? All right, let me step back for a second. The logic is right, but I am just struggling today. Okay. So the missing, so the previous sum. Well, the previous sum is also just equal to the current sum, so this is always going to be true. Just the way that we constructed it. What is the logic that I'm looking for? Basically, if the new sum, if current sum, okay, maybe I need this, but I need it after I make the modification. Nope. Yikes! What is going wrong with me? Now I'm just testing anything. Okay. So let's actually step back for a second. So I'm testing it by a good case. So let's actually look at it. No, but we're testing it because well, this will return true and it'll be good. So the thing that I should test is having a false case and first identify that, right? So let's say we have 111, 112. Then the previous sum is going to be 2, right? Yeah. Previous sum is 2, and if the previous sum is less than the other sum, okay, yeah. Previous sum is less than or equal to the other sum, then we return false. Okay, I think I confused myself with the naming a little bit. This should TLE, but we just want to make sure that it, because we have the 10 to the 9 case in there. Okay, let's actually remove it and then run again just to confirm that we're good for now. Okay, so we're good minus the TLE case. So now let's put it back in. And then now what we want is this mod. Okay, that now makes it wrong. But at least only on this one. Oh, the reason why this is wrong. I have to think about this a little bit. Excuse me. The reason why this is wrong is because this becomes missing number becomes 0, and having a missing number of 0, this is just, well, there's no way to do it. But how do I? All right, let's do something like that. Okay. And then this will allow us to kind of continue the step in one more way. And it is, I think this only happens when the other number is 1, because if the other number is 2, then what happens is that if this is 0, then you would have something like 2, 2 anyway. So maybe if this is 0, we just return, except for when n is 1. So I don't know if that's true. Let's give it a submit real quick and then see. Oh no. Oh, I have to check this first. Oh, man. Sorry, friends. I'm really like sloppy today. Also, this is 4, so. I think this is an edge case that I didn't really consider, because I think if there were more than 2 of these, this actually gets terminated early, but with n is equal to 1, that's a thing. Wow, this is a hard problem. Okay, but I did ultimately get it. I did not beat Larry from last year. Good job, past Larry. But I did match the Larry from 2 years ago. I don't know how I feel about that. Today is very yikes. I hope you enjoyed it. Yeah, let me take a look to see. Did I just... So I got it right last time. Yeah, I guess the logic is roughly the same, but I was a little bit cleaner. Yeah, I had a condition here instead. Maybe this is cleaner. This is actually, I got confused by this loop, because I think this loop does nothing. It's just a while true loop that gets broken by this or this, which is why I don't know. Otherwise, I guess it's the same idea. I just forgot about that big case. And wow, I spent half an hour fixing, so I guess I spent half an hour fixing the big case last time. And this time I only saying like 14 minutes, though some of that was just explaining. So maybe that was a little bit better. Maybe I am improving, even though I'm more sloppy as well. Yeah, and then I do some mod magic. Let's go with complexity really quick. This one is a little bit trickier to analyze, right? The question is, what is the complexity, right? Well, each number can, this is a very naive way. Maybe there's another way as well, in the sense that maybe, I don't know that this is the tightest bound, but hear me, right? So let's say you have n numbers. Each number can be halved. Like every time, because of the mod, every time you run through this loop, one number gets halved, right? And you have n numbers, and each time you halve it, you have a log n thing, right? So that means that, okay, and this is a very upper bound. I don't know that this is a tight upper bound, but okay, but let's say you have n numbers, log n halving, right? Each half and the idea here is that and I don't know if this is quite right, so I might have to think about it a little bit more in detail for an analysis, but the idea is that, you know, each half costs log n times. Idea here is that each iteration of this loop we have. Okay, so in this case, this analysis is going to be O of n log n or log n squared. But I think we could do a little bit tighter, right? Because no, maybe not. Maybe I'm wrong. What I was going to say is that you can also look at the current sum, right? So current sum is going to be, you know, n times the biggest number, but and as a result, is that a tighter bound? Okay, so you have n numbers, current sum halves every time. So it is going to be log of current sum in the beginning. But then what is current sum, right? Current sum is just you go to n times the number of bits, which is kind of, like, depending on how you want to say it. So then here, because we have this amount of iteration, we have log of n times bits iteration, and each of these iteration costs log n time for the heap. That is the complexity as well, right? Maybe, is that right? Yeah, I think maybe that's right. And of course it's n plus, well, that's just this part anyway. Am I confused? It's possible, but that said, that's not the most expensive part in that case, because it is this part, the construction of the heap. And of course you could do like a linear time heap construction type thing, I think, so, which I did not do. But and this is also linear, obviously, just going through it. So yeah, the way that I did this is n log n, and it seems like this would dominate, so this is the dominating part. Yeah, that's pretty much all I have for this one. Let me know what you think. This is a very long video, so let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.